we are going to discuss 10th standard science lesson number 1, laws of motion, part 3. So in this session we are going to emphasize two topics like Newton's second law of motion and impulse. Let us see the statements. What is the statement? According to Newton's second law of motion, the force acting on a body is directly proportional to the rate of change of momentum, and the change in momentum is in the direction of force. So this is a ball. Let us see this ball. It is in the rest state. If we apply a force, means it will be lifted from one point to another point. So the change in momentum will take place because of the action of force. So let us see the derivation for that. So let it be, let m be the mass of the body and u is the initial velocity and v be the final velocity. Then what is the change in momentum? We'll see what is the change in momentum. So what is the initial momentum? Initial momentum is p suffix I is equal to m into v, that is mass into initial velocity. Then what is the final momentum? P suffix f is equal to mass into final velocity. Then change in momentum. What is change in momentum? Delta p is equal to pf minus pi, that is equal to mv minus mu. So what is according to second law of motion, our definition, f is directly proportional to change in momentum. That is rate of change of momentum. What is change in momentum is Lv minus mu divided by t. That is rate. If you say rate of change, means you have to divide it by the time duration t. So we can write this equation as f is equal to, we are converting the directionally proportional into a constant, that is the proportionality into a constant k into mv minus mu divided by t. So this k is normally equal to 1. So f is equal to some m into v minus u divided by t. And v minus u by t is acceleration. So we can write it as ma. So f is equal to ma is our final answer. That is this is otherwise called it as law of force. The force is equal to mass into acceleration due to gravity. And the unit of this one is Newton in SI unit. And in CGS system, it is in dyne. In CGS system, it is in dyne. That is CGS system, it is in dyne. Okay. So we can define 1 Newton as. So for a mass, it is kilogram, and acceleration it is meter per second square. So we can define 1 Newton as the force required for 1 kilogram of mass to produce an acceleration of 1 meter per second square. So then we'll see what is impulse. So impulse, what is impulse? A force acting on a body for a period of time is called the impulsive force. So that we can write it as J is equal to some force into time. F is equal to force into time. And according to our second law of Newton's second law of motion, F is equal to some change in momentum. Change in momentum is delta p divided by t. So here is also f, here is also f. What is here? F is equal to j divided by t. So we can equate these two equations. We will get delta p by t is equal to j by t. So t get cancelled. Then you will get a delta p is equal to j. That is impulse is equal to change in momentum. So here from this we can conclude that a large force acting for a short period of time and a small force acting for a larger period of time. So for example, for a cricketer, in cricket, some fielder will pulls back his hand for catching a ball. In that, as the time lapses, the force acting on the body will be less. So if we catch for a less period of time means the force will be more. So this concept is used here. For a short period of time, the effect of force will be more. For a large period of time, effect of force will be less. Thank you for watching.